Bismillahirrahmanirrahim. Dear students, welcome to ECA1 lecture. Dear students, today's topic of discussion is mesh analysis. Mesh analysis provides a general procedure for analyzing circuits using mesh currents as the circuit variables. Mesh analysis applies KVL to find the unknown currents. As we people know that in the circuit analysis we have to find the values of voltages, current and power through any element. So using mesh analysis, we have to find the mesh current, and using that mesh current, we will find the other quantities. If we're going to start the mesh analysis, first we have to define what is the difference between the loop and a mesh. Loop is basically a closed path with no node passed more than once. So from the figure, if you see that from A to B and B to C, C to D, D to E, E to F and F to A, there is no node passed more than once. So we can say that it is basically a loop. Now when we define the mesh, we see that a mesh is basically a loop which does not contain any other loop in it. So a mesh is basically a part of the loop in which no other loop contained. From the figure we see that from A to B, B to E, E to F and F to A is basically a mesh. Similarly, B to C, C to D, D to E and E to B is also a mesh. We can say that this is mesh 1 and it is mesh 2 because they both are independent loop. They does not contain any other loop. But we cannot say A, B, C, D, E, F, A and a mesh because it contains two subloop which is known as meshes. Mesh analysis is only applicable to a circuit that is planar. And now, what is a planar circuit? A planar circuit is one that can be drawn in a plane with no branches crossing one another. Otherwise, it is a non-planar. So from the figure, we can clearly see that from figure A, this circuit is a planar circuit because there is no branches crossing one another. But on the other hand, in figure B, the circuit given is a non-planar circuit because you see that most of the branches are crossing over one another. If we have the branches crossing one another, it is a non-planar circuit, and mesh analysis is not applicable to non-planar circuits. Okay, a circuit may have crossing branches and still be planar if it can be redrawn such that it has no crossing branches. So from the figure, you can see that there are multiple branches that are crossing over one each other. So we can say that figure A is basically a non-planar circuit. But when we redraw this circuit, you will see that there are no cross branches in this figure B. So it is a planar circuit. So you can make a non-planar circuit to a planar circuit by redrawing it so that there is no branches that cross over each other. Now we will see that the steps to determine the mesh currents. Number 1. In the first step, assign mesh currents to each mesh. If you have two meshes, assign I1 and I2. If you have three meshes, assign I1, I2 and I3. After that, assign the direction of mesh current. In order to avoid the confusion, assign the mesh current direction in clockwise direction. Apply KVL to each mesh. If you have two meshes, apply 2 times KVL. If you have three meshes, you have to apply 3 times KVL on each mesh. Solve the resulting simultaneous equation to get the mesh currents. When you apply KVL to that meshes, you will get a voltage equation. If you have two meshes, you will get two equations. If you have three meshes, you will get three meshes. After getting that equation, you will simultaneously solve these equations to get the values of the mesh currents. In order to understand the mesh analysis, let's do an example. In this example, we have to find the values of capital I1, capital I2 and capital I3. Basically, the current element I1, I2 and I3 are algebraic sum of the mesh currents. You can see that I1, capital I1 is basically equals to small I1. Similarly, capital I2 is basically equal to small I2. So we have to find the value of I3. So I1 is equal to small I1, I2 is equal to small I2. By applying KCL at point B, you will see that I3 is equal to I1 minus I2. If we apply the KCL, what KCL states that current entering the node must be equal to current leaving the node. So I1 is basically enter the node, which is equal to I2, which is leaving the node, and plus I3, which is also leaving the node. When we simplify it, we will get that I3 is equal to I3 is equal to I1 minus I2. Now applying KVL to loop 1, we will get minus V1 plus VR1 plus VR3 is equal to 0. What KVL states that sum of all the voltages in a closed path must be equal to 0. Now apply the KVL to loop 2. We will get V2 plus VR2 plus V2 minus VR3 is equal to 0. Now you have to substitute the values in equation 1 and equation 2. The values of VR1, VR3, VR2 and VR3. Now, in step 2, use the Ohm's law to express voltages in terms of mesh current. First, you have to take equation number 1 or mesh 1 equation, minus V1 plus VR1 plus VR3 is equal to 0. Now, substituting the values using Ohm's law, V1 is equal to V1. VR1 is basically the voltage across resistor R1 and VR3 is basically the voltage across R3. So from VR1, the value of VR1 is equal to I1 into R1. I1 into R1. Current flowing from resistor R1 is basically I1 plus. Now you can see that from R3 there are two current flowing. I1 is flowing in the downward direction and I2 is flowing in the upward direction. Basically R3 is common in between these two meshes. So we can write that the value of the voltage is R3 into what is the value of the current? I1 minus I2 is equal to 0. Simplifying that equation, we will get I1 into R1 plus R3 minus I2 R3 is equal to V1. This is basically equation number A. Now using the second mesh equation, which is equal to VR2 plus V2 minus VR3. Now when we substitute the values, you will see that the value of R2 is equal to VR2 is equal to R2 into I2, V2 is V2, and from R3 you will see that I2 is flowing in the upward direction and I1 is flowing in the downward direction. So the value of the current is R3 is equal to I1 minus I2. Sorry, here you will see that the value of this thing is basically I2 minus I1. So when we are taking loop 2, the reference current is positive. If we are taking loop 1, the reference current is positive. So here there is a little mistake, which is the voltage VR3 is basically equal to R3 into I2 minus I1, which is equal to 0. Now simplifying these equation, we will get I1 into R3 minus I2 into R2 into V2. You can simplify that equation using these values. Now you can solve these two equations simultaneously or using grammar rule or using any method you have studied in the calculus. You will find the values of I1 and I2, small I1 and small I2. You will see that capital I1 is basically equal to equal to small I1. Capital I2 is basically equal to small I2. using KCL at point B, you will see that I3 is equal to I1 minus I2. So we have to find the values of I1, I2 and I3 using mesh analysis. We have to solve these equations to get these values. Now we'll see another example. For the circuit given in the figure, you have to find the values of I1, I2 and I3 using mesh analysis. This is basically your home task. You have to calculate the values of I1, I2 and I3, and we will discuss in the next lecture about this example. Thank you very much. We will discuss question answers in our live session. Thank you.